So for this example, we are going to continue our understanding of degree and radian measures. This one says use a unit circle to help determine the radian measure of the following degrees. So I have a unit circle up here. I have it broken up into these quadrants here I've done in the previous examples here. But now it says for A here, it says 15 degrees. So we want to be able to change this degree measure into radian measure. So I know that 30 degrees is pi over 6 radian. 30 degrees is 1/3 of 90 degrees, and 1/3 of pi over 2 is pi over 6. So then 15 degrees, that's half of 30 degrees. So then 15 degrees is going to be, in radian measure, is going to be half of pi over 6. So pi over 6 times 1/2, that's pi over 12. So 15 degrees is pi over 12 radian. And we're strictly using our understanding of our unit circle, both in degree measure and in radian measure. So let's try B. 75 degrees. 60 degrees that's pi over 3. 60 degrees is twice of 30 degrees, and 30 degrees we already said was pi over 6, and twice pi over 6 is pi over 3. 75 degrees, that's 60 degrees plus 15 degrees. So then, as radian measure, that's going to be pi over 3 plus the radian measure 15 degrees, which we already determined is pi over 12 in the previous problem here. So this is going to be pi over 3. That's our 60 degrees. Plus pi over 12, which is our 15 degrees. In order to add fractions, we have to have a common denominator. So this is 4 pi over 12 plus pi over 12. That's 5 pi over 12 radians. So this is 5 pi over 12 radians. Now we can check this to make sure that 5 pi over 12 radians is indeed 75 degrees. This is in radian measure, so pi is expressed in radian. If I want to change it to degrees, then express pi in terms of degrees, which is 180 degrees. So if I want to change it to degrees, then I do 5 times 180 degrees over 12. 5 times 180, that's 900 degrees, divided by 12. That comes out to be 75 degrees. So I know I'm on track. Let's try C. 7.5 degrees. 7.5 degrees is half of 15 degrees, which is letter A here. And we already determined that 15 degrees is pi over 12 radian. This is 15 degrees in radian measure. So 7.5 degrees is going to be 1/2 of that. So 7.5 degrees is pi over 24 radian. So hopefully you see what's going on here. We're not using our calculators at all. We're just using our understanding of our unit circle and making these divisions. We're just slicing up these divisions that we already know. Let's try D. 285 degrees. 285 degrees is 15 degrees more than 270 degrees. (270 degrees in radian measure is 3 pi over 2. And 15 degrees in radian measure we know is pi over 12. So we're just going to add the two together. Here's our 270 degrees. Here's our 15 degrees. Add them together. 285 degrees. We'll have a common denominator here. This is 18 pi over 12 plus pi over 12, 19 pi over 12 radians. So 285 degrees, 19 pi over 12 radian. And again, we can check this by changing our radian measure to degrees. So I can easily write this as 19 times 180 degrees rather than pi radian and divide that by 12. 19 times 180, that's 3,420 degrees divided by 12, which of course does come out to be 285 degrees. And lastly, let's try E. 97.5 degrees. That's 7.5 degrees more than 90 degrees. So you can see that 7.5 degrees right here is pi over 24, and 90 degrees is pi over 2. So I'm going to take pi over 2, that's our 90 degrees, and add that to pi over 24. That's our 7.5 degrees. This is 12 pi over 24 plus pi over 24. That's 13 pi over 24 radians. (13 pi over 24 radians). And again, we can check it by changing our radian measure to degrees. So we'll do 13 times 180 degrees over 24. 13 times 180 degrees, that's 2,340 degrees, divided by 24, and that does come out to be 97.5 degrees. So here we simply use our understanding of these measures that we know and use some simple division, multiplication, and addition to come up with other degree measures. And there you go.